Okay. All right. So today what I'm going to be talking about are, sorry, can't see my screen. Come on, go away. Okay, great. So today what I'm going to be talking about is some more details about developing your R packages. And these are some things that, you know, I have spent a lot of time scratching my head over, and, you know, it's a real, really time-consuming to figure out. So, and they were non-intuitive for me. So I want to kind of go over those and help you out a bit so that you don't struggle as much, and that you'll have these notes to look back on as you develop your packages. So I'm going to be focusing on the namespace, setting that up, your depends and imports, and your description. I'm going to be talking about passing R command check, so checking your package. This is different than installing. You might install fine, but not pass the check. So I'm going to show you some tips about like common problems with that. Then I'm going to give you an introduction to GitHub Actions. And so it should just give you a brief introduction, show you some of the things you can do with that. I found that really powerful myself. And then show you some debugging tips. It looks like somebody's not on mute. Adam, you're not on mute. Let's mute you there. Okay, great. Okay. And I'm not really going to go into intro to C++ code in your package. It's really quite easy. I'm going to give you a link to where to look. All right. So let's first talk about the depends and imports in your description file. So this is you've got a package, and you've got this file, and it's going to look kind of like this, and it's giving the information about your package. And you've got these lines here: depends, imports, and suggest. And these three lines give information about the dependency of your package on other R packages. And I'm not going to talk about it, but like you would also in here have, like if you had a dependency on, say, JAGS or Stan or C++, you're going to have some information about that dependency here too. I'm just going to focus on R packages. If you're doing the other stuff, just go look at other packages that use the other software code that you depend on and look at those examples. Okay, so let's look at, we're just going to talk about dependency on other R packages. So, so first off, the depends line. So the depends, so both depends and imports are things that the user must have installed to use your package. And when the user tries to install your package, R is going to, it's either going to fail if they don't have it, or like in RStudio, it's nice, it gives you a little like flag and it says, hey, you don't have these, do you want me to install these? So, so that's what's going to go on here. So the difference between these is that depends is going to be things that when the user installs your package, they're also going to have available the functions from that other package, or at least they're going to have available at least some. Oftentimes people provide all the functions in the other package, but you could set it up so that they only have access to certain functions. I'll show you an example of that. So let's look at this line here. So here I'm saying it depends on R, and what this part here is saying what version of R it depends on. So it's depending on R 4.0. You don't need to have this dependency on R on your depends line. The only reason you would have it is if your function depends on a particular version of R, like like the latest version, something like that. And that could definitely be the case. There was a big change in R 4.0, and so it's entirely possible that new packages you develop might depend on R 4.0. All right, but what about here? So we've got ggplot2. So what this is saying is that when the user installs your package, when they load your package, so when they say library, my new package, all the ggplot functions are going to be available to them. And imports are things that are inside your functions, and that you'll be using, but they're not intended for the user. Okay, so what I mean by this, not intended for the user, that means like when I have forecast here, the user, like when they say library my new function, they're not automatically going to be able to type, ETS, which is a function in the forecast package, and have that run. But in the depends up here, then the idea is that, yeah, they could write ggplot without having to run a library ggplot2 command. That's kind of the difference. I'll talk a little bit about how you decide where you put these. Okay, so let's get rid of that here. Okay, so depends. So because things on the depends line are intended to be exported to the user, that means available to the user. That means that if you have something on your depends line, you also need a line in your namespace. Things on the depends need a line in the namespace. That's how that goes. So here I had ggplot2 on my depends line. So then in my namespace, I want to have import ggplot2. If you're using R Oxygen to write your namespace, then what you do is you would have a file, something like, import packages.r. That's kind of a common thing that people use, and then everyone can recognize what that file is. And that's going to be in your R folder, and that is just going to have the R Oxygen code for your namespace. And it's going to look like this. So a hashtag, quote, that's your R Oxygen code, and then it's going to have import ggplot2. And that import ggplot2, what that is doing is that's importing into the user's environment all the functions in ggplot2. And then the last line in that file, import packages.r, is going to be null. It is important that the last line is going to be null. So if you have more packages than ggplot2, say, however many packages you have in your depends, you're going to have a line import for that package. If you're manually setting up your namespace, rather than having R Oxygen do your namespace, then you're going to, in your namespace file, you're going to have this line, import ggplot2. Again, whatever function packages you have. And I think you could have like multiple packages listed here. I always just do one line for each package. Okay. So let's just to kind of show you exactly how that looks here. Okay, so oh goodness. Okay, so like in this one, it looks like in my little toy one. Okay, I'm not going to use that one. Let me go to a different one so I can show you an exact example here. Great. That one also does not have any. I think this one. Yeah, this one should. Okay. All right, so here's a concrete example. So this is a little package here, and you see I have depends on ggplot2. So then in the R folder, because I'm using R oxygen, I'm going to have this file here, and that file has my import code and then the null. This code looks a little bit different. So this says import from. That would be the case when you're only importing one function from that package. So this is just a little toy example, just to sort of illustrate things. So in this one, what this line is doing is it's only importing the autoplot function from ggplot2. So because ggplot2 isn't loaded when my package loads, and everything on your depends and imports is going to be loaded. So the user would be able to do ggplot2 : and access all the other ggplot2 functions. But for autoplot, because I've done import from, they could just type autoplot on the command line. They don't have to do the ggplot2 : All right, so that's there. And then namespace, you can see this is generated by R oxygen 2, and R oxygen 2 added this line right here. Okay. All right, super. Let me just show you here. What if I change this? I can change that. I could do it this way too. And now when I install and restart, there, okay. If we go back over here and look at that namespace, there's the import here. Okay. So that actually shows me this line here. If you're editing your namespace, I'll fix this. It's not actually the @import. That's our oxygen code. I'm so used to using our oxygen code. If you're manually doing your namespace, it's going to be this import parentheses ggplot2. But I suggest that just adopt using our oxygen to do your namespace. It's good to get in the habit of doing that. I think it's a pretty standard way to do it. Okay, so that's how you're going to set up your depends. Okay, everything on the depends, got to have a line in your namespace. What about your imports? So imports are things that your package has to have to run because you're using those functions within your functions. And so within your functions, you need to use the : to access those functions. So let's go back on here. What do I mean by that? So like, you know, if I were doing, let's say I had ggplot2 on the imports and not the depends, that means that all my ggplot commands have to have ggplot2 : in front of the function. So let's go, I'm going to move this up here so you can see it. So that would mean that a basic ggplot call in my function would be ggplot2 : ggplot, that would be my data frame. And now AES is a ggplot2 function. So I got to have that ggplot2 : in front of AES. You know, say x equals x, y equals y. And then plus, now I'm going to do points, G on point. Well, that's a ggplot2 function also. So 2 and : it gets a little messy. Yeah, something like that. Okay, so that's what that code's going to look like in your functions if you have ggplot2 on your imports. All right, so one thing that can kind of trip you up a little bit is that some things that you really commonly use are not in base R, but are in, I think the stats package is really common. So you do need to declare that too, even if it's a package that would be loaded automatically. When you load R, say when you're in RStudio or something, you know, someone doesn't have to load those packages. So you need to declare that package in your namespace. So for example, if you're writing a function and that's going to use the LM, the linear regression function, that's in the stats package. So you're either going to have to put it on depends and then have the import stats in your namespace, or you're going to have to use stats : in front of any function that comes from the stats package. So that's like your LM, that's like your R norm, R binom, all that kind of stuff. Let's see, I think graphics is another weird one. I think that's the same way. A lot of the like base plot and stuff's for graphics. So you're going to have to be aware of that. So what I do is I'm like routinely, whenever I type a function, I routinely put question mark function, like, so question mark LM, and I check what package that's from. So let's see, if I were to go here, like that, I look up here, aha, it's from the stats. So if I'm writing a function in a package, it's going to be an R package, I'm not going to write LM, I'm going to write stats : LM. And I do that for every time I'm using a function from another package. The only exception really is ggplot2, just because my ggplot2 code can get so nasty, you know, all those ggplot2 : everywhere. Sometimes I won't, if I'm lazy and the R package is just for myself. If I'm making a public R package, I will always denote every function with what package it's coming from. Technically speaking, if it's on depends, you don't have to do that, but I'm going to tell you why I do it anyhow, if it's either on depends or imports. Okay, so William added a nice point here that yes, in your functions, you can put that @import package anywhere, and I don't know if our Oxygen will make multiple lines of those imports. So if you have that @imports in multiple places, if you just have multiple lines of that in your namespace, it probably doesn't matter if you have multiple lines in your namespace, actually. So that's another way to tackle it, and it's possible that's a better way to organize it for you. You know, maybe you want to keep those imports specific, you know, in your function documentation at the top, rather than trying to remember, oh yeah, I got to go remember to edit the import packages.r. You can do it either way. I like to keep mine all in one place, so that way I can kind of scan it. But it does mean that when I edit my functions, I have to remember and go over to imports. Daniel, so the alternative is to import it. You'll have to expand on that a little bit. So the alternative of using the : is to import it? Yeah, right. So if you, sorry, my dog is trying to come in. Okay, so yes, if you were to import the package, then you don't have to use : all the time. And so you might want to do that for a personal package, although or public package, there's a lot of reasons not to use that strategy. And I personally am going to use : in all my packages. And I'm going to explain why I do that, even though it seems like a hassle. It is a hassle. Okay. So, right. Okay. So what should you put on depends versus imports? So, so it depends, I think, on whether the package is just for yourself, like, mainly just for yourself, versus something that you're developing for other people or maybe a group of collaborators. So the general ethos is that you don't monkey with somebody's environment if you can help it. Like, you try to touch their environment as little as possible. So if you have like a whole bunch of packages on the depends, then when they load your package, it's loading a lot of other packages, and those packages all have functions, and what you could do is you are masking a function that they have loaded either from another package in their environment or that they have created themselves. So, one example that, I run into all the time is the function filter is in a few different packages. So if I load a package that is using the filter function and they're using it from the zoo package and they have zoo on depends, that is really annoying to me because I don't want to use the zoo. When I use type filter, I'm not expecting it to come from the zoo package. So I don't want somebody to have a package that I'm using to have zoo on the depends, because then the zoo filter package is going to mask the one I want. That can be a real hassle. So just be cognizant of that. So I tend to have as little as I can on the depends. And typically the only thing I'm going to have is, like, for me personally, what would be common is ggplot2. If I'm doing anything that has plotting, and yeah, that's for me. Or if it's something like really heavily integrated with a package I'm working on, like sometimes, like I have a package called Mars that uses another package called KFAS, and they're really integrated together. It wouldn't really make a whole lot of sense to have one loaded and not the other. So I might have, I think I have KFAS on the depends for that. Yeah, but I try to keep really minimal things on the depends, because you're basically monkeying with the user's environment by loading a whole bunch of packages into their environment. So yeah, so that's one strategy. And then right, imports. Okay. So anything that you are using in your functions has to be on either depends or imports. Okay, it has to be in one of those. What about things that you're just using in your examples or in your vignettes? So those are things like when you're running a check and making sure all the vignettes run, all the examples run, then you're going to need to have those packages installed. So you put those things on suggest, so that when R runs a check, it knows it has to have those things there in order to run your examples and your vignettes. Yeah, so Christy makes a really good point, right? To try to keep it minimal to the packages that you need. So, like, if you just need ggplot2, just use that. Don't do the whole tidyverse, which is, yeah, as she mentioned, humongous. Okay. Right. So, more points is do not ever use library or require in your functions in a package. You don't ever do that. You might do that in scripts that you're writing, right? It's not part of a package, not part of a function. You could use, library or require. We do that all the time, but you do not ever do that in a package function. The proper way to do it, you declare it on your depends or imports, and then you use the function using function name : Okay, so I talked about always using why I always use : or I talked about that I always use : So why is that? Even though it makes kind of nasty looking code. I showed here's a ggplot example. So the reason that I personally do this is that if I have a package on the imports line, then I have to do it. The only way I could get around having to do that is if I had it on the depends line. And if I have it on the depends line, then in my namespace, there's going to be a bit of code that says import. So it imports all those functions. That means all those functions are loaded. It's as if that when I loaded my library, I also did, say, library ggplot2. Okay, but what happens if, for whatever reason, I decide, you know what, I think I don't want that package on the depends. I want to move that into imports. I have a little nightmare on my hands because I've got to go through my functions, find every function from that package that, because I was being lazy and I didn't put : in there, I now have to find those. I've spent too many hours doing that. I've suffered too much. So I just no, if I'm writing a function for a package, I use : The second reason I do that is it makes my code more readable, in that whenever I read my code, I know exactly what package a function is coming from. And that's helpful for me. And also, if I decide, you know what, I don't want that dependency anymore in my package. What if I'm only using one, little utility function from a package, and I'm just going to write my own code for that purpose? I want to get rid of that dependency. All I have to do is search for, XYZ. If XYZ is the package I'm getting rid of, search for XYZ : and I can find every example where I've used that package in my package. So that really speeds things up for me. So that's why I do that. Okay, so, right, okay, good, 10:30 here. Okay, so I'm going to talk about these dependencies and figuring out where you forgot a dependency or forgot a : somewhere when I talk about passing R check, because R check is going to check if you properly declared everything. And it's going to complain if you have something on imports and you didn't use : Okay. So, so I'll talk a little bit, one last comment about the strategy. So I talked about, I tried to have minimal dependencies, and especially if I have a package that's used by a lot of different people. Like I have a really big public package, and I have only 3 package dependencies on that. I got to keep that minimal so that it doesn't cause problems when people are trying to install it. On the other extreme, I have this other package. It's called Sardine Forecast. It has to do with my sardine papers, and I have every package in there that I've used in my analyses ever. And it's convenient for me because when I load it, bang, it loads up all the packages that I need. Well, I have also about 10 different collaborators, and having that many dependencies is a nightmare for them to install. because, you know, they've got all different versions of R. They're on Unix machines. They're on PCs. Some of them are on Macs. I spent so many hours because I had so many dependencies. So it is a real problem if you have a whole bunch of dependencies. Okay. So let's talk about passing the check. Okay, so what do I mean by passing check? So this is if you're at the command at a shell, the system line, the command would be R CMD check. And let's go ahead and do that on this one. Show you how you do that in RStudio. So this is a package, and I'm on the build tab here. I go here more, and now I run check package. Okay. So a few useful things. It's going to show you what function it's using. So you can see it's using DevTools check. And that is going to set some defaults, which you may or may not want. I'll show you how to change that in a moment. And so it tells you what it does. It's updating the documentation. It loads it, writes the namespace. Okay. So it said that it didn't like things, so it didn't pass this check. And now you can go through and see what was the problem. Okay, so you can kind of go down through here. Okay, so it didn't like that I didn't have a license on here. And it's not liking that I didn't have my dependencies quite right. And then it's also complaining that I've got some problems in my documentation. So I'm going to have to go through here and just sort of, you know, plug away at this and find all these cases where I left off things. So probably in little forecast, I've got something that looks all right. Maybe hello. That's okay. Not sure where the problem is. Maybe it's an example or something. Imports not declared. Yeah, so there is. Oh, okay. Oh, I see what's going on here. Yeah, see, now you can kind of see how it can be hard to really figure out, oh, exactly what's going on. What is it complaining about? So here it's complaining that I don't have this license. So let's just do GPL2. That would be kind of a standard one for us for a government a product. And now I'm going to do imports, and I need to have forecast and ggplot2. So that there, and now let's try it again, check package. It didn't like something. Oh, okay. One. Okay, so now I'm down to one. Okay, so now I'm left off. I've got some problems with my my documentation that I need to fix. Okay, so you can kind of see how that process works. And you know, I don't think I've ever done a package where I didn't have lots of things to work through check. And what I recommend as a workflow is, like, don't leave off that check to the end. You're just going to have just a ton of things to work through. And your package could install, and you work just fine without passing check, but the check is good to pass. It's just showing you that there are kind of issues. It's kind of like having typos throughout your package. Some of them will be things that, are real problems, but a lot of things, like here with, I've got problems in my documentation, that's basically a typo. Okay, so let's go back here and kind of talk about some of the check problems that are a little cryptic. Okay, so this one, if you use ggplot2 and dplyr functions, you maybe more with dplyr, because I didn't see that happen with this. It didn't run into. Let me check in this code if I have this going on with. No, I didn't do that. I didn't. Oh, okay. I don't have any. In that one, I don't have this ggplot code that looks like this. Okay. So what you can get is if you use ggplot2 or dplyr functions, you get these weird errors about undefined globals. And like you'll have a bit of code that looks like this, and it works absolutely fine at the command line. You run your function, it works fine, and it will not pass check because it says undefined globals. And what's going on is that to pass check, it wants you to be more explicit about where this X comes from and where this Y comes from. And, you know, that can make sense. It's trying to make your code really robust. And let's say that this data frame df did not have a column called X, but you had defined X earlier. So what would happen is that this code wouldn't fail. It would just, use the X that you had defined earlier, even though that was probably a bug, right? You probably meant for this to have a column called X. So to pass check, you're going to have to be really explicit of what X you want to use. And so if you want to use the one from here, this is the data argument. If you do !ggplot, you'll see that the first thing is data equals, and the AES is actually mapping. So what you do is you do .data, so it's talking about the argument within this function, $X, and then .data, $Y. And obviously, this isn't necessarily X or Y. It's whatever you called those columns. You're going to come find this same thing if you use any dplyr functions. So, like if you use dplyr select, you're going to get a complaint from check about undefined globals here. You're going to have to do $X if, say, you're selecting the X column from that data frame. The same, your arrange, filter, all the dplyr things. So this one, took me a long time to figure out. It's kind of hard to find the help on that. If you use pipes in your functions, this piping is actually a function in the migrator package, and you're going to have to declare that package in your description, and you're going to have to import it. So the code that you would use in your R Oxygen is going to be import from that. If you're doing your namespace manually, no, it's not that code here. To get rid of that there, it's going to be import from parentheses, migrator, comma, that parentheses. Okay. So you're going to have to declare that if you use pipes in your code. Here are some common things that, I'll run into. So errors like undeclared global functions. That usually means I forgot my colon somewhere. Undeclared global variables. It's usually, for me, a bug. So actually, I have an undeclared global variable. That could be the case. Or if it's appearing in a ggplot2 or dplyr function, it's that thing where I have to, be explicit and say .data. This problem where you've got this .data and having to do it like that, that looks really easy in like that. But if you use ggplot2, you know that your ggplot calls are not simple like that. Like it's going to be this really complex thing, and so you might be needing to use this .data in kind of multiple places throughout your ggplot2 code. Oh, excellent. Christine says there's a version of the pipe in base R 4.1. So if you don't want to have to import from Gritter, then you would do a dependency in your depends thing. You could say depends R parentheses greater than or equal to 4.1. But be aware that if you do something like that, and you put that depends on 4.1, that means that somebody who has R 4.0 is not going to be able to install your package. So I'm a little careful myself for packages on putting a dependency on a really recent version of R, because it can make it a real hassle for people to install if they haven't updated R yet. Especially for us in the federal system where we often don't have admin access, then updating R means you have to contact IT. So I found that in the federal system, sometimes people are a little slower. Okay, great. Another common one is that your examples have problems, and it can be sometimes hard to figure out what example it's complaining about. If you go into, there's going to be a folder for your check. Let's see if I can see it. I forget where it is, where it shows up. Can't quite remember. There's a folder that'll show that has all the check information. It's being loaded to a temporary file. You can look there, or you kind of remember that it's going to go through them alphabetically, and that can kind of help you sort out where the problem is. Because sometimes, like they'll say the problem's one place, but if it's like a forgotten parentheses or something, it can be higher up. So that's just a tip there. And then another thing is just be aware that if you have like don't run or don't test, that it can be a hassle getting our command check to respect that. And these are just some tips here to do that. Another way is that if you go into tools and you go into project options, you go into build tools, and you go into, where is it? No, it's build tools. Oh yeah, this thing right here, use DevTools package function if available. I often will I will uncheck that if I have don't run in my examples, because DevTools check function hard codes in a run the don't run. Don't know why it does that, but it does. People have been complaining about that, but it hasn't been fixed. Okay. Oh, thanks, Daniel. So sounds like you can. I haven't tried updating R myself on my computers without IT. I will try that. Okay, great. Okay, so those are some tips there. And on the R GitHub Actions part, I have some other tips if you have a don't test or don't run in your examples. So you might have like examples that take a really, really long time to run. So then you'd put like don't run, so that when you are running check or installing, doesn't. I think it's mainly for when you're like running check, it doesn't run those examples. Okay, great. I'm going to move power on because I'm going very slowly here. This section here just gives you a little tip about writing S3 methods, which are super easy. S4 are more robust, but S3 are super easy, and I use those all the time. I find it really handy. So this is like writing a print function or a plot function, and yeah, Daniel, you'll have to research S3 versus S4. S4, you are kind of defining an object and all the structure of that object, and you write all these kind of tests for make sure that object is kind of the right form and everything. And S3 is basically what I'm going to show here. You just set the class. So let's throw an example of writing an S3 method. So this is like a plot method. I'm going to do a print method here. So let's say you had a package where you do a linear regression, and let's say you have this kind of code in your functions, and so it returns this fit that is a certain linear regression that you do. And what you could do is say, okay, I'm going to call all my fits, give them the class foo. You can call it anything. And so what I do is I just update the class of that. So this is each thing is an object and it has a class. And an LM class, well, it's certainly LM at least. It might have some other classes. But I want to add as my first one this thing that I'm going to call foo, because it's my fit, and I want to have a special print thing for that object. So I just update the class just like that. And then I'm going to write this print function, and it's going to have this format. It's going to be print dot my class name. And then in this case, I am going to have it just say, you know, hello, this is a foo object, and then print out the R squared. And then in my namespace, I'm going to have that here. The format's a little different if you're using R Oxygen 2. Okay, so, but if I have that in my function, if I have this set up in my package, then whenever somebody gets this fit, they use my function and they get that fit. When they type fit at the command line, it doesn't type what you would see for a LM object. Rather, it's going to say, hello, this is a foo object, and this is your R squared. And that I have found is actually, you know, it's a little extra work to write those, but it's really handy if, like, you have particular output that you want people to see, like particular plots that you want them to see when they plot the objects that are created in your package. You can really increase the usability. All right, okay. Debugging tools. These are my tips, and please throw in there in the chat if you have any other tips about debugging tools, and I'll add those to this list and add those to the Q&A summary. I use debug a lot. This allows you to step into a function, any function. Allows you to step into it and go line by line. If you're using RStudio, then so let's do debug little forecast. In this case, I'm debugging my own function, but like I said, I could debug any function at all. Okay, so what? I might not have exported it. Okay, good. Okay, so the problem there is I didn't export a little forecast. That's okay. So let's do hello. So you see I jump in here, and now I can just kind of walk through the code. And you can see there's a problem here, ABC. Okay, great. So the nice thing here is look up here. These are things that allow you to jump through for loops, which is really handy if you have like complex functions. So you don't have to go through each step of the for loop, you know, hitting return and going to each iteration. You can just here jump forward. I forget which one it is. It's one of these that allows you to jump forward. So it is easier using debug in RStudio. Options recover can be nice. if you do that at the command line, so if you're, here, if you do it, Q is going to get me out of that. If you do that here, then what happens is when your function runs into an error, it's going to put you into browser, so you jumped into that function. Traceback will show you where the problem was. If you're using RStudio, it will automatically show you this, unless you tell it not to. There's some neat functions to get at the speed of things. System time is a really simple one. You just do system time and whatever that function is, and it'll show you how long it took to run. But profiling is much more powerful, and that will show you exactly the things that are taking up time in your functions. And this can be really, really helpful for figuring out what things are slowing down your code. And sometimes it can be things that you would not expect. So here I did a cross product. And this happens to be this transpose here. I think it's the transpose. Like if you have really large matrices, doing this right here is actually really slow, and I think it may be because of the transpose is a slow thing. It's not slow in this example. This is a tiny little matrix, but if you have huge ones, that gets slow. So you would want to use a cross product function. And you might not guess that. You might think, oh no, that doesn't take up much time, but it does if they're really big matrices. So I use that all the time for that. Another nifty one that I like is the micro benchmark package. And you can compare different functions and then plot it out. So like here, I'm comparing different ways to add things together. And you can see that if I use the sum function, that is slower. This is the time, slower than if I just did 2 plus a. You might not guess that, right? So it's about 10 times slower if I put it in times the sum. Another example, this shows kind of how piping is slower. So this, I've set up a function where I use piping, versus a function where I just kind of embed this in a whole bunch of parentheses. And you can see this function 1 is the piping one, and you can see that it's slower than the one without piping. Thanks, Andrew. Andrew's saying that ProfViz is pretty nice too. I'll check that out and I'll add that to this. Okay, I'm going to skip over byte compile. I don't know if that's still a thing with R packages. It was about 5 years ago. It could really speed up your code. But I haven't looked if that's still a thing. I just kind of automatically put that on my big packages. You might play around with it. I found that I could get like a big increase, like 25% faster by just saying byte compile is true. Okay, so I'm not going to go through this. Look here if you are having people install your packages from GitHub, because there are some big headaches that your users will run into, especially if they're on PCs. And this gives some tips about things that you can you can tell people to help them out. I put this on my README, so in case PC people are installing, they have tips. Okay, I want to jump ahead to GitHub Actions and explain a little bit what that is. So the GitHub Actions are things that you can set up so that when an action or when something happens on your GitHub repository, then an action can be done. So let's give a concrete example. So like if you push code up to the repository, what you can set it up to do is you go off and it runs the command check. So like if you see this badge here, command check passing, that's from a GitHub action. So that when code is pushed up to the repository. It's for an R package. It goes, installs that a repository on another server. It installs all the dependencies, runs command check. If it passes, you get the passing badge. If it fails, it's the fails badge. So that just automatically does that. So you can, you don't have to remember to run check. You can just see immediately whether it's passing check or not. That's one simple example. I'm going to give you a bunch of other examples of things that you can do with GitHub Actions. Getting started, I find to use this package really easy. So use this command and then kind of read about what it says when you, or just do question mark, use GitHub Actions and read about what it's going to do. And play around with it on a repository. Let's see if I can put it here and show what it does. So what it's going to do, it creates this folder called .github, and then it's going to create this folder called R workflows, and then it adds a kind of an example workflow, which is the R command check YAML. And it wants to add some badge code for me, but I don't have a README, so I can't do that. But that's okay. It went ahead and it set up the key thing, which is in here, workflows, command check YAML, right there. And there we go. There's the example code that it is. I'll walk you through kind of what's going on. Basically, this on part is saying when should GitHub do this action, and it's saying on a push to the main or master branches or a pull request. So you can tailor this to when you want things to happen. This is just the name of this action, and then this is the job that's going to be done on this other server. So basically, it's kind of setting up your environment here. It's checking out the repository. It needs to install the dependencies for your package, right? So it's looking at that description file and installing it. So it's going to need the command, R command check. That's how it's going to do the check. And then once it's all done, it's going to run here. It's running this R command check for you. Yeah, so that's basically what's going on there. So, okay, writing your first one. Well, first, you can just use this. If I were to push this up to GitHub right now, GitHub is going to see that I have an action, and it's automatically going to run that for me. So it just happens automatically. So there's lots of ways that you can use GitHub Actions. And getting started, few different ways. Okay, so here, look in GitHub, this repository here, and read the README, look at all the examples, and then you just start playing with it. Look at other people's examples. Okay, go on in the Fisheries Integrated Toolbox, you're going to find some examples. You're just looking for that folder, .github/workflows, and check out other people's examples. Here's a blog post from a colleague who putting together their first GitHub action. I found that really useful. There's a book about it. I didn't find that quite so useful because it was kind of like trying to get information from a fire hose. Here's an example in this data package that I'm developing. And so I don't have our command check here. Rather, I have one set up so that when the teammates push to data raw, those are these CSV, these raw CSV files, it's going to process those. it's going to process all this, these headers and create all the documentation files. So this is kind of a, a custom one that I wrote, and you can see, how I set it up to do when things are pushed to data raw. I only want it to happen then, and then it installs my repository, and then I need this package, so I tell it to install that. So these are kind of all the steps that it's going through, and then I have a function which is in the R folder, so I source that. See, up here it installed the repository, so it has all those files now on the server. So I'm going to source that, and then I run that that function, and that is what is going to process all those data files for me. And then this adds all the changes, and then it pushes them back up. So that's just an example of kind of a complex thing that you can do. So now I don't have to be monitoring this repository and run, process the data raw whenever one of the teammates posts to that folder. It just happens automatically. And then this one here looks to see if this has run, and then it updates the website. So if you go here, here's the website for the data. So whenever the teammate updates the data information, all the help files are updated, and then this website is rerun. I don't have to personally do that. It just happens automatically. And you can set things up so that, like, when people push to your repository or you push to it, that you update to a branch, and then you have set up a pull request so that you don't automatically go update to the production version. I haven't done that yet. I know it's possible, but I haven't personally done it. I am going to set it up like that on this, but I have to learn how to do that. Okay, so where am I? Here. Let's go back. Okay, great. GitHub Actions. So poke around here. I have some links here. If you have any other links for places, if you use GitHub Actions, I have some tips. I'll post those to the chat, or you can email them to me. I'll add those to the notes for people. I will also note that there are many other ways that you can use GitHub Actions, and there are a few interesting videos on YouTube, and I suggest watching at least some of that just to kind of open your eyes to what is possible for automation. It was really an eye-opener to me, really helped me think about different things that I could do. Okay. And lastly, 7 minutes over. Okay. Lastly, if you want to integrate the C++ code, there's a nice section in the R package handbook. Just go here and read up on the use RCPP. Read up on the RCPP package. It's quite easy and can really speed up your code. And you would do this like if you had a section of your code that was pretty computation intensive, you could create a C++ version of that particular section of code. All right, okay, that's the end for the lecture. Let's open it up for questions, comments, anything. Go ahead and unmute yourself if you want. There's not too many of you on this call today. Okay, while you're thinking of questions, if you have any questions. So next week, I'm going to be on this call and it's just going to be an open Q&A. So if you have something you want me to go over, you need help with, hop on the call. I'll just have the line open. If nobody's on it, I'm just going to be working. So yeah, just hop on tomorrow, and I'll help you out with whatever you need help with. Okay. Yeah, so Andrew, yeah. So if things that you have on your suggest are not required for installation of your package, they will be required to run examples. And so let's see kind of a example of this. Okay, so here's my little forecast, and if I want to have at examples, so examples, okay. So it would be common in your examples to use library. Okay, so that's totally fine. So you use library there or require, and then now you could use LM, A, tilde, B, whatever, something like that. Okay. So now I've got this example, but it uses this package here. And so the users can run your, install your package, use it just fine without having the stats package installed. But in order to do check, you would need to have this installed, because it can't run this example unless that is installed. So you would have on here in description, you're going to have suggest, and now you need to do stats. You'll notice on here, I've got knitter and R markdown on here. And that is because if you have vignettes that are RMD files, so like this, that would be, that's the standard now. Very common. So if you're going to use that, then you're going to need knitter and at least knitter. I bet you need R markdown too on there. That's why that's there. Those are there. It's because of the vignettes. Okay. So suggest. Okay. Could you walk through a debugging example? Yeah, sure. Okay. So let's see. See if I have something. Okay, this is. Okay, I'm going to start with this simple example, and I want to pause for a moment and say there are some tools you can use in our studio somehow, like setting breakpoints, and I don't ever do that, so I can't help out with that. I do it the way that I'm going to show, and if anyone has other ways to do this, jump in there. So so first off, I'll kind of show like debug. So my new package. So I'm going to have to do : because I think that's going to. It's not an echo. Fine. Okay. 3 because I didn't export it. Okay. Great. So what was going on there is that if you look here, I did not export this, so it's not in my namespace, so it's like a hidden internal function, so I need to use the 3 colons there. So now I can do this, Yeah. Okay. So let's run this function with ABC. So this function, it's not going to work with ABC because that's a text, and what this is expecting is like time series data or a vector or something. But let's go ahead and run this. So now it's going to jump in there, and then you go through, and then, okay, I got an error. Okay, so there's a problem. So now when I want to do it again, I go back in, and now I know I had a problem here. So now I'm just going to say, okay, it happened in this line, and I'm just going to copy that. I think I could just run that. There we go, run that. Okay, so I see the line is here, and now I can kind of stare at that, and then maybe, you know, run data, and, you know, see that what the problem is. Okay. So, so that's one way that I will do it. Another way is that let's imagine that this was a massive function, and another thing I could do is I could put this thing right here, browser, and I want to stop right there, enter the browser there. So I don't want, like, I've got, like, say, you know, 100 lines of code above this, and I just kind of want to ignore that. Or I only want to enter the browser under certain conditions. So, you know, let's say I had, you know, a for loop here, I equals, you know, 1 to, you know, a huge number. And I know the problem is happening at a certain point. So I could say, there we go. Okay. I was watching on the side there. I had those pluses show up that was telling me I had a problem. So I could do, you know, if I equals 10, I know that's when I'm having the problem, then I can enter browser. So I'm going to save that. I need to go build, install, restart. Okay. And now when I run this, I don't want to have ABC here because, okay, there. So now I've entered a browser right here when I equals 10. So now I can do I and that, and I see that that's 10. I can change the values of things. So I can look at, data, says it's 1 to 10. You know, I could change that. You know, or something like that, monkey around with it. So, you know, I'm now inside the function. I can change things around. Okay. And, oh, I can also, I'll show you. Okay. Show you one other thing, how you can. Okay. Oh, darn it. Okay, so here I want to debug this. And now I go here. And now you can see I'm just hitting return and stepping through. I think I can just do next here. Yes, so this is next. And now I'm going to be what if I wanted to get down here, right? Now I'm just kind of stuck. I've got to do this 10,000 times. I definitely don't want to do that. And so I can go here, execute the remainder of the current function or loop. So that should take me, and that pops me through. That's a really helpful thing I found if you have things like for loops. Yeah, so you're right, you can insert, how do I, yeah, there, okay, there's a breakpoint. So I want to stop debugging this, so let's try this out. So Eric just mentioned this. It's not being debugged, really, okay. What it was. Okay, I want to try this. Okay, so I've got the breakpoint here now. So now it should, if this works, it should stop there. Yeah. Yeah. Right. Okay, so that's a much easier way to do it than putting the browser in there. Okay, so Celine, I hope that helps. Yeah, so next week, yeah, hop on there if you have like a concrete example of trouble that you're having with the debugging, and I can give a example more tailored to what you're having trouble with. So William, no, I have not discussed using two-factor and or PATs for GitHub, and I haven't done that myself, so I wouldn't be any help there. Okay. Any other questions? As I said, feel free to unmute if you want. Or tips, if you have your favorite debugging tip. I will. I'll put another debugging tip in there. It's more like a testing tip, and so I am working at getting more familiar with the. I think it's called the Test This package. So setting up test for my packages. So yeah, the test that package, unit testing. I'm not a huge fan of it. And it may be because I'm not all that good at it, even though I have done a lot of it. Made a lot of tests. What I mean, it is really handy, but it can be hard. I have found personally creating the kind of test that I need. So, like, I'm trying to discover if a simulation is producing the right answers. Made a bunch of changes in my code, and so, like, a lot of times, like, what I might need to do is I need to compare the answers between two different versions of my package, and I need to compare all the output. So things like that, I've had a hard time using test that with that. A different way that I've done it is like I'll do models in my package that can also be fit with other packages, and so I compare them, and if they should have the same answers. That's been kind of powerful. Another thing that I'll do with test that is whenever I write a function, I write a test that will test all the arguments and make sure at least nothing like fails. A really common problem that I run into is that I will test a few different possibilities for a function. Let's say I have a function, I have 2 arguments, and each argument can take 5 different values, right? So that's like 25 different combinations. And I will kind of set up some examples in my, for the function and for my vignettes that will kind of go through maybe 5 of those. But there's really another 20 options that I haven't tested. And so that happens to me all the time where I've got a few different combinations that don't work. So I use test that to go through all those to make sure that everything works. And invariably, I'll find examples that doesn't work. Another handy thing that I do that just sort of a habit for making my code more robust is when I write a function like this. So I just, as a habit, I write sort of my little test for the arguments at the top. And so, I would do something if not is integer in years, then, I'm going to do, stop hey in years must be integer. So I do this all the time, just all these little tests at the top. I just have a section for functions. I didn't do that here. This is just a toy example. I'm talking about my real work. I'll do that. Another handy thing is to go ahead and use the match.arg feature for functions. So let's say that you have an argument called type, and it can only have 3 different values, and they are red, blue, and green. So the cool thing about this is that when people do question mark for your function and they look at the usage, it's going to be really obvious to them what are the options here. They are red, blue, and green. And then you can use this code that's called, you would do type gets match.arg type. So what that's going to do is it's going to look here. These are your 3 options, and it's going to see if the user passed in one of those 3 options. And if it didn't, it's going to say, hey, that's an error. It can't be that. That's a really handy thing to do. It's only going to work if your options are factors, something like that. So it doesn't, unfortunately, work if it's like 1, 2, 3, fortunately. But if it's something like this, match.arg works great.